Okay, so back to the power supply. Now that we understand power, AC, DC, now we're going to actually take a look at the inside of the power supply and really, in more detail, how it functions and what it's trying to do, okay? You need to know this information because what do you think probably one of the most common problems you have with computer components?
Burnout?
It's usually power, okay? Usually you have a power problem that has caused another component to fail or is causing intermittent failure, okay? So when you have certain kinds of issues, as we'll look at here in just a second, you've got to go look at that power supply and you've got to go test these circuits, okay? So it's important to know on these connectors, okay, on this 4-pin Molex connector, what are my voltage ranges? What are these supposed to be testing at? So that I can get my voltmeter out and start going and testing them, right? Now, if I'm testing for volts, what do I need to have on?
Power.
I need to have power on, right? If I don't have power on, can you test volts?
No.
It's totally different than testing resistance and the fuses and things and the switches that we talked about earlier, right? And that was testing the resistance in those circuits or the continuity. This is different. We're testing volts. We got to know what the volts are. We need power to test volts, right? Sounds like common sense, but you'd be surprised, right? This is just another different mini connector. Okay, see this on a floppy drive? You need to know those voltage levels. Okay. These are good resources for you to hang on to. You're going to need to go take labs. There should be a lab in the back of your chapter that says, you know, take a multimeter, go test this stuff,
Hey,
right?
I have a question. Now, whenever we do come to those labs and we do it, and a lot of time we write it down on paper, whatever it is, when do we turn that stuff in?
Let's talk about that after we get done.
Okay.
Okay, because then I can kind of wrap that up, all right?
Okay.
Here are two different kinds of power connectors that are going to connect to your motherboard, okay? Just like when we had form factors on our motherboards and our cases, we're going to have form factors on our power supplies too. Okay, what's the difference between these two? Because this is a real key difference that you're going to have to learn in upgrading and paying attention to power supplies. What's the obvious difference?
They're bigger.
One's 13 pin and the other's 11.
One's 20 pin and one is
10. Wait, what?
2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
20, and the other one is 20.
Well, this is the same up to here, and there's
4 more.
4 more pins,
24.
right?
Uh-huh.
So one's 20 and one's
24.
24. You need to know that, okay? 20 pins and 24 pins, because there's different kinds of power supplies. Sometimes you can buy adapters and use them that way. Sometimes you can buy one that'll do 24 or 20. It just has a little pigtail that peels off. Okay, but you got to pay attention to those specifications. This is good information to know. What are these voltage levels that these are supposed to be reading at? And what I also need to understand is, where is pin 1? Okay, because if I turn it around, pin 1 is in a different location, right?
Mm-hmm.
So you got to understand, according to your connector in this little notch, where pin 1 starts, because if I had this turned around and I thought that was pin 1, what would that be reading?
5.
Plus 5, when pin 1 actually should be
3.3.
Yeah, okay? So you got to pay attention to that stuff. So there's another picture of the ATX 20 pin, okay? ATX 12 volt, which is the 24 pin, okay? Okay, in our troubleshooting, we get a power good signal sent from the power supply to the motherboard to verify that it's functioning normally during
The post.
Power on
post.
self-test.
Remember we talked about that post, power on self-test, okay? We actually go in through a self-test that says, hey, yeah, power's good, okay? And then we can continue in our normal boot up process like you read about in operating systems, right? Okay. Standby power, you guys know the difference between your computer going in standby or sleep or being shut down altogether, right? Okay, because there's different power components where if it goes to sleep, certain things get turned off and certain things don't get turned off versus being shut down or just hibernating. So there's some key terms there you need to look at. Standby mode, I'm not going to go into a lot of detail because you guys can review this, but there are two ways to actually control that sleep or hibernation or the ability to wake that computer up too. And it's either in the BIOS or in the operating system. Okay, and so that's what I really want you to get out of it is that you can control that in the BIOS or the operating system. And this is where it's at. Advanced Configuration and Power Interface allows the operating system to control power management versus Advanced Power Management allows the BIOS to control power management. You need to know the difference between those two, okay? Because it is important. If it's the operating system, then you've got to go establish those settings on how you're going to control that power. Okay? When you want your computer to go to sleep and what you want turned off if it does. Things like that. How soon will it go to sleep? Okay? It's just some more information about that. We're kind of running out of time, so I'm trying to hurry through here. So here's an example of your OS controlling that. Another example, different operating system. Which is an ATX form factor?
That one.
This one? Because the other one was ATX plus what? 12 volts, right? Power saving design that is managed by the operating system?
ACPI.
That's right. ACPI. So the other one was?
APM.
By the BIOS is APM. Very good. I'll let you guys read the troubleshooting. Key things. The fan in the power supply is not working. If it's on fire. The circuit breaker is tripping. Okay? Automatic rebooting. The computer just keeps rebooting itself. You see that a lot. Electrical shock. You touch it and it's shocking you. Excessive heat. You can tell it's really hot. All those things. And then matching up your specifications. Okay? We almost made it through. Okay? I got
What's our
decent time. Okay?